Mazak has come out with smooth chamfering. This allows us to machine a consistent chamfer using a small chamfer tool and moving along the Z-axis while rotating the C-axis. Let me show you how to program this in today's Mazak Minute. Hi, I'm Mike Zillich, part of the HEH technical team. Today's Mazak Minute is going to be smooth chamfering of a hole on a cylinder. Mazak has developed cylinder chamfering. Gives us the ability to chamfer on the outside. Machining is performed with a chamfer tool and a vertical mill head. And when you go to select your operation, we're going to be in what we refer to as the ZC mode, which is going to be the Z and C axis machining at one time. To get started, what we're going to do is we're going to start with a blank unit. We're going to go ahead and hit point machining. From point machining, if you look over on the first set of soft keys, I want you to press high speed drill use. This is going to allow the drill to drill first and then have us come with a chamfer tool as a second tool. So high-speed drill use first, then we're going to select drilling. On the mode select, we're going to choose ZC soft key. This is going to put us machining on the outside diameter. And we're going to enter the values for the diameter, the depth, and the chamfer. The diameter is going to be the size of the hole that we're going to be drilling. The depth is going to be the incremental depth of the hole from the starting surface. And the chamfer is going to be the amount of chamfer to be machined. If we look at the sequence data, you're going to see now that we have a drill out. We have the 0.31. I'm going to be drilling a 5/16 hole, a ½ inch deep. And you come over to your cutting speed and feed rate, and you're going to see, based on the material of the tool, you're going to select high speed, auto, coated high speed, carbide, or insert. Where I'd like to make a change is going to be, if you look at the second sequence, you see how Mazak automatically comes out with a center drill, which again, that's going to give me a heavy spot on two sides and not a constant chamfer. But we're going to change that center drill out to a chamfer out. So you move your cursor to where it says center drill, and then I'm going to go down on the soft keys and choose chamfer. I'm going to move the cursor over to the nominal diameter size. And what I'd like to do now is that for end mills, face mills, chamfer cutters, and ball end mills, we have to register the tools in what we call a tool file library. To get there, while you're on that nominal size, if you look down at your soft keys, you're going to see a soft key that says tool file. When you go to that, a screen's going to pop up, and what I'd like you to do is move your cursor below the last entry under the number. You're then going to go over and hit input on the keypad, and this will enter a number 2, or the next sequence number of the library. From there, there's going to be a couple topics that we need to answer. The first one's going to be nominal diameter. If you're in inch mode, which most of the machines in the US have, it's going to be a 2-place decimal. If you're doing metric machines, your machine's configured in metric, it would be a 1 decimal. The minimum diameter is going to be the 2-place decimal, and this is going to be the minor diameter. The tool material is going to be high-speed carbide or cermet. And then what we need to know is how many teeth are there or cutting edges do I have? This is going to be used for when we calculate out the speeds and feeds. And then finally, the angle is going to be the angle of the chamfer. Mazak will automatically calculate out the depth of the tool based on the interference dimensions that we're going to give it. And if you look at the picture on the right-hand side, you're going to see that the angle comes from the horizontal line coming up to the cutting edge. Once we have the tool defined, we're going to go ahead and hit the program soft key. And that's going to take us back to the program. Now we're still on the nominal diameter, but now what we can do is to reference the tool file library. There's a soft key called the tool file window. We're going to select that tool file window and pick the tool that we want to use. In this case, you can see in the picture that I chose the 1/8" chamfer tool, and it's got 4 cutting edges. Go ahead and select the OK tab, and that returns me back to the sequence data. Now I've labeled a bunch of the fields in the sequence data. The first one's going to ask me for the tool diameter interference. It wants to know that if I have a shoulder up against where I'm chamfering, it wants to know what that distance is. When you're doing a round hole, you can see how in the picture they're showing 20 millimeters. They want me to enter 40 as a diametral value. So what we need to do is double the radius. On the right side picture, what you're seeing is that if there is no interference, a lot of times I see customers putting a 0 there, but that's telling you that the interference is right on top of the hole. What we need to do is we need to put a large number in there. If we're doing metric, you would put 99.9, again being a 1-place decimal, or in inch, which is most common, you're going to go ahead and enter 9.99, a 2-place decimal. The second item is going to be the distance. This is going to be if I'm chamfering down inside the counter bore, this is going to be what is that distance down. If I'm chamfering at the top of the counter bore, you can see that the depth is 0, as well as on the right side when there was no interference, the depth of the machine hole would be 0, which is that top face. Number 3 is the prepared hole diameter. That's going to be our drill size. 4 is going to be our prepared hole depth. That's going to be how deep we drilled the hole. And the cylinder selection for chamfering, this is the biggest one that I want to make a note of. When you get to the rough, this is where we can select the standard chamfering or clockwise cylinder, counterclockwise cylinder. For the next number 6, you're going to enter in the chamfer width. 7 and 8 are going to be your cutting speed and feed rate. You can manually enter those, or you can hit the auto set soft key. And then under your M code columns, we can put an 8 there if you'd like to have coolant. Coming down to the figure pattern, you're going to see when we're on the machining on the OD cylinder of the part, you're going to have a selection either point or arc. In the example we're going to be doing today, we're going to go ahead and choose point. And the diameter of the part that I'll be machining is a 1-inch diameter piece of stock. So I'm going to enter the radius of 0.5. The X coordinate would be entered if we have the XY input selected. And that's going to be highlighted green. In a few screenshots ahead, we're going to go ahead and cover the differences between the two. Number 3, if I have the XY input turned off, then I'm going to enter in the C axis. And if the XY input is highlighted green, then you enter the Y axis. So just to recap, we can actually program the point in 2 different methods. We can go ahead and program the radius and the C degree of the chuck, or we can enter an XY coordinate. And normally it depends just how it's programmed on the print. Then finally, we're going to have number 4 and 5. We're going to enter the Z-axis coordinate, how far we want to be in, and the Y-axis coordinate, how far off center line we want to machine. This gives us a little bit of what the difference between the XY input in is. When it is not highlighted green, you're going to go ahead and set the RC coordinates, which is the radius and the angle as they are. If you notice at the right side or view, you're going to see that at the 12 o'clock position is C0. If I go counterclockwise, that would be a positive C axis. If I go clockwise, it would be a negative C. And you can see I have circled the radius, R, the C being the degree, the Z being how far into off the face of the part are we going to machine the hole, and the Y would be the offset from the center line. The next print is going to show us when the XY input soft key is highlighted, and you'll notice that it will be green. Now what we're going to do is we're going to be entering the values in what we call our XY coordinate. You're going to enter the data while that XY input is enabled. What you're going to notice is that the numbers that you type in, I believe if it's in an XY input, they will be yellow, whereas if it's the radius and C degree, they'll be white. When you're looking at the XY coordinates, if you look at the axes that I have drawn up, X positive is going to be 12 o'clock, Y plus is 9 o'clock, X minus 6 o'clock, and, excuse me, let's start over again there. X plus is going to be 12 o'clock, Y plus is going to be 9 o'clock, X minus is going to be 6 o'clock, and Y minus is going to be 3 o'clock. If we look at the diagram on the left, you're going to see that you see the small x and the small y. That is establishing the position of the degree that the C-axis will rotate. If you think about it, basically that's going to be your Pythagorean theorem. X squared plus, or x squared plus y squared is going to give you the C squared. So when we go to look at the toolpath, the biggest thing that you're going to notice is that on the position page, you're going to see that it's going to move over in X and X, Y, and Z, and the C-axis to the beginning or the center of the hole. And then what will happen is it will come down in the X-axis, and it's going to go ahead and arc into the cut. And if you look on the right side, you can see how the toolpath is going about. Let's go ahead and jump to our SmoothCam software, and let's go ahead and do a demo. So I'm in the SmoothCam software right now. I'm going to come over here to Program. We're going to go to Work Number, and I'm already on my program that I need to be on, so I don't need to change the work number. But in the common unit, what you're seeing, I got carbon steel, the OD max 1 inch, ID minimum 0, and I have a part length of 2 inches. I go to do a drilling operation. And to get there, you're going to hit point machining, high-speed machining, and then drilling. For the mode, we're going to go ahead and choose the ZC. Give it the diameter, the depth, and the chamfer. The drilling information is going to be 0.31. It's going to be a 1/2 inch depth. Now this pre-diameter, pre-depth, that gives us the ability to slow down the feed rates to a different percentage if we're breaking through a part, if it's a through hole. The first one under pre-diameter is going to be the distance that you want to stop short of, and then the pre-depth is going to be the amount of, or the percentage that you want to reduce it by. A lot of times I might see people maybe go 70 or 60% just to reduce it, especially if you're doing cast iron. Under rough, this is going to be your drill or your different pecking operations. If you are doing pecking, the depth will be your amount of peck, and then your speeds and feeds. The second tool, this is where I had us change. When I click on the tool, you're going to see down below on my soft keys, I choose chamfer. It's on the outside. And then if I come to the nominal size, this is where you're going to see down below I had you guys go in the PowerPoint. We went to the tool file, and this showed us the library. If I wanted to create a new one, again, I would click here and then hit input. I'm going to go ahead and go back to the program. And once you establish your library, a lot of times you don't have to go to the tool file. You can just go to the tool file window, and this is going to show you the list of what tools already exist in your library. You're going to highlight the one you want and simply say OK. The hole diameter, if you notice the prompt here, it's saying the tool diameter interference. Distance point R to the cutting point, because there is no interference and I'm on the largest OD of the part, I'm starting at 0. The diameter of the hole prepared is going to be 312. The pre-depth is going to be a 1/2 inch. And then when I come to the roughness, this is where you see the standard clockwise cylinder, counterclockwise cylinder. These two here are going to give me that consistent chamfer. I enter the depth of the chamfer under the depth, and I give it my speeds and feeds. When I come down to my figure pattern, we're going to come over here. I'm going to select point. Now here is where you see that soft key that I was referencing, that XY input. That's going to be the soft key right down here. If it is not highlighted or it's not in green, that means I'm programming the radius and the C degree. If I do highlight that, then that's going to be using that X and Y coordinate. And just remember that 12 o'clock would be your X positive and 9 o'clock would be Y positive. So with that, I'm going to go ahead and put it at C0, or first off, it's a 1/2 inch radius. The C is going to be at 0 degrees. I'm going to machine the Z at 3/4 in from the face of the part, and it's going to be on the center of the part. The last item over on the right-hand side, you're going to see the R. That is going to ask you, do you want to go out to the initial point or the R point? Okay. The initial point will take me out to the OD max, whereas if I was machining a hole on a turned down diameter, I could leave the tool just off the face of the, or off that OD and not pick it all the way up to the OD. Since I'm only doing one hole, it really doesn't make a difference. But if I had several holes or I did an arc, that's where, do I want to pick all the way up to the outside diameter or leave it close down to the turn diameter? So let's go ahead and take a look at the toolpath now. So I'm going to come over here, I'm going to hit my far right key, program complete. We're going to go ahead and go to toolpath, and I'm going to do a 2-view of this. So I'm going to hit this orange icon. I'm going to go to plane change, and there is a XZ, XY. And then what I also like to do here is I like to rotate the view of the shape of the part or of the tool path. Not that I'm rotating the C-axis coordinate, but it's just the view of it. I'm going to come down here to angle input, and I'm going to type in 90 degrees. And you'll see down here on the bottom part of the screen, you see the 90 degrees. I'm going to go ahead and scale into the part. So I'm going to come over here. Let's do a scale change. And my hole is about 3/4 in. It's someplace about here. If I look at the top here, I see it's at 0.52. So I'm going to go ahead and change that scale to 0.25. I'm going to go ahead and hit input. And you can see how that opens it up. If I do a part shape, you can see I see the hole. And what I want you to notice is that I'm at C 90 degrees and the Z 3/4, X 1 inch. As I hit step, okay, I come over. This is going to be the drill hole. It drills down. It comes out. I'm going to go ahead and hit path erase. And now I'm coming over with my chamfer tool. Okay, remember I chose that 1/8 chamfer. That chamfer tool is above the X is above the diameter. Y is in the center line. Z is there. C is at 0 degrees at that 12 o'clock position. As I hit step, you can see it moved over. And again, I like the 2 view because I get a top view of it, and I can see that my C-axis rotated. And if I look at my position screen over here, you can see I'm at that 14.7 degrees. Now as I hit path step, you're going to see it plunges down, okay? And it will automatically calculate out the depth of, based on those interferences and what the depth of the pre-drill was. Now when I go ahead and hit step again, it's going to give me a 360 cut. But if you watch the C-axis up here in the position, you're going to see that it's rotating about the C-axis and the Z. Okay, giving me a consistent chamfer. I'm going to go ahead and hit path erase. And if I hit path step, it basically just comes out of the hole and we're complete. So what a great feature to be able to machine a consistent chamfer. Thanks for watching the Mazak Minute. Hopefully you found this very informative. If you have any comments or questions, please leave them below.